Welcome to Grade 12 Advanced Mathematics. In this video, let's explore on how to apply differential equations concept and to find the general solution.
Welcome to HSM Spot Math. Let's spark our math skills together.
Let's kickstart with question number 1. How will you rewrite y prime? Dy by dx. So, dy by dx is equal to 4y. Now, let's group the y on one side, x on the opposite side. So, let me bring dx to right hand side and y to left hand side. So, it becomes dy by y, that's equal to 4dx. Now let's integrate. As 4 is constant, I keep it outside. What is the integration of dy by y? Exactly, ln y. That is equal to 4. What about integration of dx? Very good, 4x plus c. Now to get the value of y, and to remove this ln, we will write e raised to ln y. Let's raise to the power of e on both sides. So it becomes e raised to 4x plus c. Next step, there is a rule when you write e power ln y, it's nothing but y. That's equal to, here again you have plus, isn't it? When you split it, it will actually become e raised to 4x multiplied by e raised to c, using law of exponents that you studied in your small classes. Now e power c is also a constant, so let me name it as capital A. You can name it any alphabet. I chose capital A, e raised to 4x. This is actually the solution, but you are supposed to find the value of a. For that, we will use our initial condition that's given as y of 0 is equal to 2. So your x value is 0 and y value is 2. So let me substitute that. 2 is equal to capital A, e to the power 0. 4 multiplied by 0 is 0, right? So what's the value of a? 2. Now let me look at the option. Starting y equal to, it's not given, so I can start with the a value, that's 2. So you can rule out option B and option C. E to the power 4x, because the expression is given here. So 2 e power 4x is nothing but option D. Let's try out question number 2. Whenever you see y prime, that is dy by dx concept, so hereafter to make it faster, you can bring y to the other side, so it becomes dy by y, that's equal to 3dx. If you can skip the first step, that's also fine, as you handling multiple choice. Now when you integrate and you're done with the integration, you will be getting as y is equal to a e power the value which is given here, okay, 3x. So if you can skip the steps, that's fine, but to know more in depth, please rewind back and check out question number 1. There I have explained it in detail. Now you can substitute your x value, that is 0, and your y value, that is negative 2. So when you substitute here, you will get your a as negative 2. So let me look for the options. Let's cancel option A because negative 2 is not existing. Even option B, because it's also here, it's not the standard form. Either option C or D. Now e power positive 3x, right? In that case, the final answer is option C. Let me continue with question number 3. Same setup, same scenario. So let me check with a direct integration value. Y equal to a e power Whatever the coefficient of y, that will be placed here as negative 3x. Please make note, only if the differential expression is given as y prime is equal to negative or whatever it is, the constant y in that form. Okay. In short, you can have a note y prime that's equal to ky format. Only k is a constant. Okay. It could be positive or negative. Only if the format is like this, you can directly substitute the answer as capital A e power whatever the value of k, that one multiply by x. Got it? Now you will substitute the initial condition. Please note this is x, your 0 is x and 5 is your y. So let me substitute, and that time you will get your a value as 5. So let's check out not B, not D. What about A and C? You have negative 3x. In that case, the answer is option C. Let me continue. Same setup, same scenario. So y is equal to a e power. What is the coefficient of y? Very good. So you get negative 2x. Now let's substitute the given initial condition. So you get negative 6 is equal to a. Let's look for negative 6. In that case, we will rule out option A and option D. Let's look for negative 2 in the power. That gives option B as the right answer. Now when you move with question number 5, same scenario. So let me fix y is equal to a e power 2x. Here again, be careful, this time your x value is not 0. What is it? Exactly, it is 1 and your y value is 2. So you get 2 is equal to capital A. Be careful, okay? Don't simply write A is equal to 2. No, it is not. So e power 2 multiplied by 1. If you use calculator, you will get it in decimal. But look at here, you have in your answer E. Have you noted down that? So your A value, we will write it as 2 divided by e power 2. Because you get here a e power positive 2. When you bring it in the denominator, it will be e power 2. So when you bring it to the numerator, it will be negative 2. Are you getting me? Now let me go and substitute in your expression. What is your a value? It is nothing but 2 e power negative 2. And already you have e power 2x. Let's group it because you have a same base. When you have same base, you will add the powers. So what is it? Negative 2 plus 2x. Let's search in the options. Sorry, here 2, okay? It is not y. 1 second. Accidentally I wrote y here. It is 2. Yeah. Now you can cross out option A because you don't have 2. Then e power, we have negative 2. So you can cancel option D because it's negative 1 and cancel option C because it has nothing. So option B is the right answer. Clear? Now let's enter to the final EOT 30. Same concept. We are going to find the general solution of separable differential equations of first order. Let's dive into our first question. So if you notice here, let's first group it. So it becomes dy by dx, which is equal to, I'm going to split it, 2x over y. How to split? E power y times e power negative x. Let's bring all our y's on one side and x on the other side. At that point, you will get y dy. Also, you have e power y, isn't it? So e power y will come to the denominator as e power y. So when you bring to the numerator, it becomes e power negative y. That's equal to, you already have a 2, you have a x, e power negative x dx. See, there is a small trick behind it. Whenever you see a variable e power negative same variable d with the same variable, the formula could be negative the variable plus 1 e power negative y, which is equal to, a constant is a 2 and you have a negative sign, then you can notice x plus 1 e power negative x. So you can have this concept intact. So I repeat, you will find a negative, then that variable plus 1 e power negative variable. Got it? So here why 2 extra? Because already you have a 2 as a constant. That's why. Now let's cancel this negatives on the both sides. So you get y plus 1 e power negative y. That means you can rule out option B and option D. Then the right hand side you have positive 2 because you cancelled negatives, isn't it? So positive 2, both the place positive 2. Then you get x plus 1 e power negative x. Unfortunately, option A and option C are the right answer. So both are correct answer. That's an error from my side. I'm so sorry for that. Here, let's write y prime as dy by dx. Already it is split denominator in x and numerator in y. So let us group in one single step. Dy over root 1 minus y square. And dx will go to the other side, so it becomes dx over x ln x. Left hand side, no issues. You get sine inverse y when you integrate. Integration of the left hand side is sine inverse y. But look at the right hand side. For that, you need to depend on the substitution method. So you will consider your u as ln x. When you derivate, your du becomes 1 over x dx, that is nothing but dx over x. Got it? So now let's try to substitute in your right hand side integration. So already dx by x will be replaced by du over ln x will be replaced by u. So the integration is, can you guess? Ln u. Now ln, what about your u? Ln x, right? So let's replace now our right hand side with ln absolute value of ln x. See, you can see option A is the right answer, but the simplest form matters, right? So y is equal to our sine inverse I transposed. So it becomes sine of what? Ln x. Got it? Sine of ln x. That is option D. Now let's move to question number 3. That's very simple. Y prime can be rewritten as dy by dx. So when you group, you will get sine y dy. That's equal to cos x dx. So let's integrate. We have the formula direct, so we need to just hunt on our given options. It becomes negative cos y is equal to sin x plus c, which is option B. Let's move with question number 4. This is also a pretty easier one, but need to recall our trigonometric ratios. So first let us group it, okay? dy by cos square y, which is equal to x dx. Any idea how I am writing dy by dx? Please note y prime can be written as dy by dx. From here we are grouping y on one side, x on the other side. Okay, fine. Now let's integrate. But before we integrate, x dx. One second. It is not x dy, it is x dx. Okay. Now x dx, no issues. It is x square over 2. But what about the left hand side? This cos square y can be written as integral sec square y dy. But what is sec square y dy? It is tan y. So you get tan y is equal to x square by 2 plus c. Again, the simplest form matters. So y is equal to tan inverse. Tan will go to the other side as tan inverse, and the whole function on the right hand side will come as an angle. That is x square by 2 plus c. Not angle, as a value. So which is option B, because tan inverse is same as arctan. So answer is option B. Now let's move to question number 5. Here, if you notice, x over 1 plus x square can be grouped as x and y can be taken to the other side. So it becomes dy over y, and already you have a x. Dx will be brought next to it over x square plus 1. See, the left hand side can be written as len y, no problem. Len y. But on the right hand side, your denominator has x square, right? So when you derive you get 2x. 1 less on the numerator. So 2 is missing. So if you want to include a 2, you should divide by a 2. Now forget about the 1 over 2. Look at here. When you derive the denominator, it is nothing but the numerator. That means you can apply the concept of len. But half is existing. Don't forget that. Now len x squared plus 1 plus c. Now your aim is to remove len. How to remove len? You will go for e power concept. When you lift your lens to the power of e, your half can be written actually as root of x square plus 1. So e power len root x square plus 1 plus c. You need to recall the concept. Whenever you have half log a, this half can be taken to its power, so it becomes log a to the power half, which is nothing but log root a. This is the concept we used actually for len as well. So e raised to. Now what happened? E's get cancelled, so it becomes y is equal to. Also this e power c we can rewrite as a main concept option A, root x squared plus 1. So when you look at it is nothing but option A. Now let's move to the final question of our EOT. Question number 6 of EOT 30. Here already they have grouped for you in the question. In case if not, you are supposed to identify the common factor, that's y, and take it outside. Got it? Now what about y prime dy by dx? So when you rewrite dy, already you have a y here, right? So when it go to the other side, it becomes y dy. That's equal to 2. And your dx will come to the right side, so it becomes dx over x plus 1. Left hand side, as usual, the integration becomes y square by 2. But look at the right hand side. What is in the denominator? X plus 1. So when you derive it, it becomes your numerator. But 2 is existing. So don't forget that 2. And we can apply the concept of len as the derivative of the denominator is the numerator. Also, don't forget your integration constant, that is plus c. Now let's cross multiply. So you get y square is equal to, what is 2 multiplied by 2? 4. Len absolute value of x plus 1. Now plus 2, it is a constant, right? So when you multiply 2 with c, it becomes 2c. That's again a constant. So you can replace with just c, that's enough. Or if you want, you can replace with another variable. As in the options they mentioned c, I am also going along with c. Now let's hunt for the option and you get option A as the right answer. Don't confuse with B because B doesn't have y square. Okay. So yeah, that's it. So my dear lovely girls, we are done with the entire EOT recordings. Keep watching, keep revising. Practice makes you perfect. Any queries, don't forget to comment below. See you in the next video. Bye-bye and wish you good luck. May Allah bless you.